Hello everyone. Today I am building a dummy load for ion getter pumps, and I thought I'd take a moment to explain how it works and why this is such a useful tool for troubleshooting vacuum systems. Let's start with a quick overview of how an ion pump works. Ion pumps are commonly used in systems like electron or ion columns to achieve high vacuum, which is pressures down to 10 to the minus 7 to 10 to the minus 10 millibar range. Inside the vacuum chamber or the column, stray molecules drift around. Some of them wander into the ion pump, which has electrodes charged up to a very high voltage, up to like around 5,000 volts. That voltage is so high that it actually ionizes the gas, giving the atoms a charge. Once charged, they're accelerated to the metal plates and they get embedded there permanently. So the pump gradually removes gas from the system. That's why it's called an ion getter pump. It gets the ions. Now here is where it gets useful. When those ions move between the plates, they generate a small current. And by measuring that current, the system can estimate the pressure. If there's more current, that means there's more gas molecules and therefore a higher pressure. The software reads this current and either uses a table or a formula to calculate the vacuum level. Sometimes during maintenance, we're not sure what's wrong. Maybe the power supply is acting up, maybe the pump has failed, or maybe there's a real vacuum issue like a leak. To figure that out, we can swap in a known resistor called a dummy load where the ion pump would normally connect. Because we know the voltage and the resistance, we can calculate the current using Ohm's law. That results in a fixed pressure reading from the software, or it should. If the pressure looks good with the dummy load, then the power supply is probably fine. We know the issue lies either with the pump, the cable, or maybe even a vacuum leak. This is a consistent way to measure systems and isolate problems. Here's how the resistor values correspond to pressure readings. 200 megohms simulates about 1.2 times 10 to the minus 7 millibar. 5 gigohms, around 5 times 10 to the minus 9 millibar. 50 gigohms returns about 5 times 10 to the minus 10 millibar. So by choosing the right resistor, we can simulate different vacuum conditions. I'm going to build 3 of these fixed load cables using high voltage resistors. These are rated up to 10,000 volts and 1 watt of power, which is plenty since the current we're drawing is extremely low. These dummy loads are handy for troubleshooting, and I can even ship them out to our engineers in the field. All right, now that we've covered ion pumps and how they work and why dummy loads are useful, let's head over to the bench and build one. Okay, so we're going to be making a dummy load for an ion getter pump power supply out of I just cut the end off this cable, and then I have a 50 gig ohm resistor here, and the goal, we're going to end up kind of doing it like this, so we'll be able to read the 50 gig ohm, and that's the ultimate goal here. So the first thing we're going to do is we're going to cut about 28 millimeters off, which happens to be about that size. So let me take 28 here. So I'm just going to mark it here. I got my cable cut. I'm not sure if you can see. Just barely any blade showing there. I'll put this here. And then I'm going to go around a couple times. Now, cut it just about perfect. Take that off. Just take all these shielding cables out off to the side here, every strand. There we go. I'm just going to twist them a little lightly here. And now this is a dual layer here. I am just going to take these on about the 18 gauge just going to take off this much. Now you see just a little bit there. Now, just good. Now what I want to do in order to get these to kind of hold in place is I'm just going to cut a little band of shrink wrap. Put that in there. I'm using clear shrink wrap so that it's possible after to read in the resistor value just in case I lose a label or something. Now it's held in place there, and I should be able to do my soldering. You can see you can still read the 50 gig ohm. Okay, so now I'm ready here, set up for my soldering. So the first thing I'm going to do, turn my soldering iron on. Hot here. Yep. I'm going to heat this up here. Alright, now look here. There's a little solder on there. I'm going to go ahead and solder this other side. Nicely soldered. Okay, so now this bottom side here, I'm just going to solder it right here. This one's got quite a bit of mass, but I've got my soldering iron set at 738 Fahrenheit, so it's got quite a bit of heat. Okay, now I got that soldered in. Next thing I'm going to do is I'm going to put some shrink wrap over each one of these joints here. Heat down here. My goal is just to make this as mechanically stable as I can. Alright, so I've got that now shrink wrapped. I'm going to cut a small shrink wrap here. Let's see, take these and I'm going to clamp this off here while it's still hot. There we go. Shuts that off. Now I'm going to put in one long shrink wrap. It's hot. I'm going to clamp it. Alright, there we go. So now we have it finished here. You can still see 50 gig ohm there. Alright, so that's that. So let's go test it. Okay, looking at the screen here of our FEI V600 instrument, you can see the ion pump is here. Currently, IGP3 is at 7.5 e to the minus 8 millibar. We're going to test out our 50 gig ohm resistor. So first off, what I'm going to do is I want to turn this ion pump off. Okay, so on the back of the ion pump power supply is this cable here. This goes up to the ion pump. I am just going to replace it with our 50 gig ohm resistor, and then we'll go back around and turn off the ion pump. Turn it back on. Okay, now that I have the resistor installed, I'm going to turn this ion pump on. I'll make a logarithmic graph here. As you can see, the graph here is bottoming out at 1.49. Oh, it went up here a little bit. Let's let it stabilize. 3.9 to the minus 10. Yeah, so it's working, and I will label this to be about 5 e to the minus 10 as a test, so then we can test our power supplies. Okay, so now let's switch this back, take our dummy load off, ion pump back on, and now we're back in business.